Once again, college algebra. This is 11.4, problem number 68 as an example problem for the word problems. Let me read it. Two recording devices are set 2,400 feet apart with the device at point A to the west of point B. At a point between the devices, 300 feet from B, say right here is 300 feet, a small amount of explosive is detonated. The recording devices record the time until the sound reaches each. How far directly north of point B should a second explosion be done so the measured time difference recorded by the devices is the same as that as the first detonation? So something above here we want to know that'll have the same time difference. And therefore we should use a hyperbola. So when we're thinking of this, A and B will be our foci, focus 1 and focus 2. Right in the middle is our center. Let's put that at 0, 0. And that means that these foci will be at 1200 and at negative 1200, 0. That also means that this point where it's been detonated will be a vertex for the right side of that hyperbola. That says that when you measure right and left, there's another one over here. This is 300 from that. That means 900 in between. That'll give me the 1200. So I know what A is. I don't know what B is. A is 900. B, you don't know yet. C is going to be the distance from the center to a focus, which is 1200. So I can find B. This is B, this is A, and C would be that hypotenuse. So A squared plus B squared equals C squared. 900 squared plus B squared equals 1200 squared. When you square those, you get 81 with then 4 zeros plus B squared. And this is 144 with 4 zeros. So B squared, when you subtract the 2, you get 63 with 4 zeros. And B, if you need B all by itself, usually we just need B squared. Rounded 793.73. Which sort of makes sense, I guess, then. Okay, so now we know what that is. 793.73. But it's the squared stuff that we need. The A squared and the B squared. Because if we can write an equation for this hyperbola that describes the situation, we can just solve for the y coordinate. This is just another point, xy, on that hyperbola. We know what x is. It's 1200. We solve for the y coordinate, and that'll tell us how far above B we'll need to put that. So that explosion would be. So how do you do that? Well, if we centered this at 0, 0, and it opens right and left, then it's an x squared over a squared minus y squared over b squared equals 1. But we know what a squared is. It is 8100, or not 8100, 81 with 4 zeros. And we know what b squared is. 63 with 4 zeros equals 1. We know what that x has got to be when we plug that in. So you plug in the 1200, square it. 81 with 4 zeros. 63 with 4 zeros equals 1. If If you start reducing the stuff, because this is 144 with 4 zeros and 81 with 4 zeros, those 4 zeros really can be canceled. Minus y squared over 63 with 4 zeros equals 1. So I'm solving for y. So a negative y squared over 63 with 4 zeros equals 1 minus this 144 over 81. And then you multiply by a negative, we'll say, 63. So y squared is 1 minus this 144 over 81 times a negative 63 with 4 zeros. See, y squared then comes out to be, amazingly, 49 with 4 zeros. And if you take the square root of that, it's 7 with just 2 zeros, or 700. So this distance should be 700. And that's number 68.